Hello and welcome to this tutorial on OCP or Open Close Principles. OCP is one of the 5 software solid design principle. In this tutorial, we will understand what the principle is, why it is required, what are the problems if we do not follow OCP, and what are the benefits once we follow the OCP. So with that, let's get started. My name is Arjun Thakur and you are watching Tech Pros. So the first thing first is, what is OCP? So OCP says that your code should be open for extension but closed for modification. Now it might sound slightly strange that how can you close your code for modification but you can still extend this, right? So we will see that with the help of a code example. So let's look into the code. I'll show you some code first, then we will see what are the problems, then we will apply OCP on that code, and from that we will understand. So over here we have this package OCP before. So before applying OCP, what we have is, so let's say we create a class dragon. Inside that we have a method. So we have a breathe method and we print something from there. Let's go ahead, create another mythical animal. We have created a class unicorn and let's say it has a method attack. So let's say we print unicorn sparkling attack. We are going to create an application class. So in the application class, let's create a method animal action. Now this method would be able to take any type of object as an input because we can have any type of animal object here. So let's say it will take object animal. So this method will have one input parameter which will be of type object. For those who are not from the Java background, object is basically the super type of all the types in Java. So it's kind of super class of all the classes, whether they are Java standard classes or user defined classes. All the classes have the super type object. So over here, what we will do is we will take any animal as an input and then perform some action on it. So what we need to do is, if animal is instance of, let's say, dragon, if animal is an instance of dragon, what we need to do is we need to do animal.breathe. So basically what we are doing is we are converting this animal to the dragon type and we are calling breathe method on it. There is an alternate way of writing this code, which is we first cast it. So for casting it, we do dragon is equal to, so this way we would be able to cast it, and once we have casted it, we can call the breathe method on it. Now imagine the animal is of type unicorn, then what we will do is, if this animal is instance of unicorn, and this time we will directly use the shorthand, what we'll do is we will call animal dot attack. For running it, of course, we will need a main method. Let's do that. Let's create an object of animal application. So let's create a dragon object. Then we will create a unicorn object. Now you can hold these objects into their respective types, or you can even hold them into general type, which is object. right? So it's so now what we are going to do is we are going to call this animal action method on the dragon, and next is we will call the same method on the unicorn object. Okay, so that's pretty much all about the code. So let's run this. So the application has run, and as expected, it is giving us the required output. So the application is working just fine, but here is the problem. It is not following the OCP principle. Let's see how. So tomorrow, let's say we have another mythical creature or another beast, let's say a dinosaur. Then what needs to change in the code? So first thing, of course, we will need to create a dinosaur class, which is fine. But the problem is with animal application. See this animal action, right? Over here, you will have to change this code or you have to change this class. Why? Because it is so far only accommodating for two type of beast. One is dragon and another is unicorn. So if you want to add another one, you have to change your code. So basically, if you want to extend the functionality of your code, you have to modify your code. Now OCP says that your Now OCP says that your code should be open for extension but closed for modification. We definitely want it to be open for extension because we want to extend it for dinosaur, but then it should be closed for modification, meaning we should write the animal action method in a way that we don't have to modify it over and over again, right? So I hope you understand where exactly does the problem lie and what are the disadvantages of modifying the code over and over again. First, like we discussed in single responsibility principle as well, that if your code is modifying, then it is prone to errors. So you want to minimize the modifications in your code, and in some cases you may not even have the luxury to modify your code. Let's say it is someone else's code or it is some library code that you are using, so you cannot modify it anyway, right? So now we will rewrite it in a way that it follows OCP. So what we are going to do next is we are going to create a package. After, now we will just copy everything from before and paste it into after. We have copied the code from, so we have copied the code from before to after because we don't want to touch the existing code again. Because if it is available to you on GitHub or some other platform, you can always look at the before code and the after code. So in the after code, what we will do is we have a dragon class and then we have a unicorn class. So what we will do is we will create a hierarchy, right? So both of these dragon and unicorn will inherit from some super type. It could be an abstract class or it could be an interface. So let's first create a new interface. Let's name it beast. We have created an interface beast. Now it will have a method void action, and because it is an interface, we just want the method to be, so it will have a abstract, it will have an abstract method called action. So we have created a beast interface, and let's have a beast action method here, void beast action. Now what we will do is we will make both these classes, dragon and unicorn, implement this beast interface so that there is some uniformity in the code. All of them will have inheritance or extend. So all of them will have a super type called beast, and our application class will find it easy to act on a single interface rather than acting on multiple different implementation classes. So let's go to the dragon class and make it implement our beast interface. Now, of course, this beast interface has a beast action method, right? So what we will do is we will just change it to beast action, and by default all the interface methods are public, so we also need to make this method public. Similarly, in case of unicorn, we will also make it implement the beast interface. And again, because the interface method beast action is public, so what we'll do is we will implement it here and make this method public. Done this, now we go back to the application. Over here, the code was changing over and over again. What we will do is we will rewrite this whole code. Now over here, what we will do is we already know that the animal that we are going to get will be of type beast. So let's change it to beast. And over here, all we need to do is to just call animal dot beast action. We also know that whatever object we are creating, right, whether it is unicorn or it is a dragon, it will always going to be of type beast. So let's change it to beast. Again, this dragon will always be a beast. You can change them to beast or you can keep them as they are, but the good practice is always to change them to the super type that you are aware of, right? So you have just changed them to beast and now your code will work just fine. As you can see, we have very much reduced number of code over here. Let's run this first. So let's run this first to validate that we have the correct output. We should have the same output once we run this. Our code is closed for modification because whatever animal we have, we will just always have this code. So now our code is closed for modification, but then there is one more point we need to prove is whether it is open for extension or not, right? So previously in the before code, if we see that every time we had a new animal, we had to add another if statement, which we do not have right now. So we can say that our code is closed for modification. Now let's see how our code is open for extension, right? So previously for extending it, we again had to change the animal action method, right? But this time in the new application, what we will do is we will only create another, let's say we have another beast called dinosaur. As usual, we will also make it implement the beast interface. So in the beast section, we have just printed one statement, dinosaur walks to shake ground. Now let's go back to the animal application. Over here, let's create an object of a new beast. And over here, finally, we will again call the animal action method. On this dinosaur object. Now remember, we have extended our application functionality or we have extended our code without even modifying anything in the animal action. Now, of course, we need to modify this main method, but then these objects can be injected by any dependency injection framework as well. We will learn about dependency injection and dependency inversion in the last tutorial of this solid principle video series. But you understand the point that this class animal application and its method animal action are closed for modification, but they are open for extension. Let's finally run this. So it is running as expected. You can see the output. So if it was helpful, please do like, share, and subscribe. Once again, my name is Arjun Thakur, and you have been watching Tech Pro School. Thank you very much, and I'll see you in the next one.